Hello guys, in last video we calibrated a PA controller. Now we will go for a PID controller. I changed the control structure to the PID. All the other steps are same. Now the pre-tuning has started. Now the pre-tuning has finished. Now we'll check the PID parameters. The gain is 9.4 and TI is 2.4, DI is 0.42. Now we will fine tune the system. Now the fine tuning is finished and the status is system tuned. Now we'll check the parameters. Just change it to proportional gain 1 and the integral time 11 and derivative action time 2.5 seconds. Now we'll check the system. Now I have increased the output flow. We will check the stability of the system now. As you can see, now the system is stable. Now we will try to lower the set point. Now you can see that the set point is almost reached. So that's the PID controller. Now we will check the warning lights, set point limits, high, set point limit low, input warning high, input warning low. For that I am going to use this PID controller itself, and after watching this we will wind up this PID and SCADA side of our project. For setting up warning system, we have to change some settings in configuration window. We will change this process value high limit to 980. That means even though the capacity of tank is 1000 liter, we don't want to fill the tank beyond 980 liters. And in the lower limit we will put 30. In another way we can say that if we put any value beyond 980 or less than 30 in set point field, there will be an alarm. Now we'll look process value monitoring. We will put warning high limit to 950 and warning low limit to 60. One thing to notice is that the warning high limit should be less than this process value high limit, and warning low limit should be higher than the low limit, process value low limit. So if the liquid level is less than this, there will be an alarm, and if it is beyond this, there will be also an alarm. Now we will upload these parameters to the PID. Now we will upload these values to the PLC and we will run. Then we can see the warnings and errors during this process. Now I will start the main pump. As soon as I start this pump, there will be an alarm at the set point limit low, because now the set point is 0 and we set the set point limit low alarm at 30. See, there is two alarm, set point limit low and input warning low, because the set point is lower than both of them. Now we will put a set point. Now the set point low limit alarm has gone, but the input warning low is still on because the level is still 0. As the process starts and to go beyond 60, this alarm also will go. Okay, now the level is 70 and the alarm is gone. Now we will wait for the level to reach the set point. Now the level is stabilizing. Now I am going to set point to 990. As I enter 990 set point, the high alarm will be active. See, and as the level go beyond 950, the input warning will be also active. As the level go beyond the 990, the error light will be also active. Then we will change the value to 900 back. Now the error will go. So that's the warning system in this PID block. So our PLC and SCADA side is finished now. There is one or two things left to discuss, like how to take these values from the PID block for displaying in HMI. I'll show you that. In the PID compact configuration section, there is a parameter view block. Go to parameter view and you can see the gain, TI and TD here. Take the data from here and move it to some memory locations for displaying in our HMI. And in the main block, I have also placed a date and time block for data logging. If you guys have any doubts about anything till this point, please let me know in my comments. I will try my best to solve it. So that's it. Our PLC and SCADA side is finished now. In the next video, we will discuss next section of our project. So thank you. Keep watching.